I'm doing my PhD in science communication at the Australian National Centre for the Public Awareness of Science. And what I'm doing is looking at how the word science has been used on Twitter. And for my analysis, I'm using IPython Notebook and Python Pandas. And after Jessica's talk this morning, maybe I should have titled the talk, How IPython Has Changed My Life. So, how many of you have seen IPython Notebook? Yep, it's getting more each time, that's great. And how many of you are actually using it day to day? Much, much fewer. Okay, hopefully that'll change too. So what I'm going to do is just start up the IPython Notebook and run through the features that, for me, make it really useful for research. So IPython Notebook is started from the command line, and but before I start it up, I always use virtual environments, and that's really a topic for a whole other talk, and I'm not going to go into it very much. But if you're doing anything where you need to go back later and be able to reproduce earlier results, then I really recommend you have a look at Python virtual environments because they're invaluable. They let you try out new software by making a copy of the virtual environment you're currently using, try out new software. If it works well, then you can keep moving forward, leaving your old copy of the virtual environment behind. And it lets you go back at any time to repeat earlier results, even if the underlying libraries have changed. So to start the actual IPython Notebook, that's the command line that's used. And it's the PyLab command tells it to load the matplotlib.pylab symbols into global scope. So in an IPython notebook, it's an interactive environment, and you've got to always remember that you're working with anything you've run in that notebook will be in the scope of the whole notebook. It's not just each little bit of code. It also loads Matplotlib in under the alias of MPL and NumPy under the alias of NP. And then the final little bit of the command, the inline, that's just to make your Matplotlib graphs appear in the notebook instead of popping up in a separate window. So you run that, and the backend reports the settings it's using as it loads. So I've taken out the blue text out of all the subsequent lines just so it would fit on the slide at a size you could see. So once it's finished starting, it opens up the notebook in your default browser, and this is what the index page of the IPython notebook looks like. So on this index page, you can drag in an existing notebook if you want to add it into your current directory, because what it's doing is showing you the notebooks that were in the directory that you started the IPython notebook in. You can open one of the existing ones that are in the list, or you can create a new one. In this case, when I took my screenshot, it's actually not just been loaded, because you can see the thing next to the example of an IPython notebook that says shut down, and that means that notebook is already running and has a connection through to that back-end server that we started. And you can see at the top that the other tab is there, that there's actually I've already opened one of the notebooks. So that's a way that you can see what notebooks are still running. Even if you've closed their tab, they might still have a connection back to the background notebook. So this is when we look at then the actual notebook page. This is what it looks like. So in this case, I'm typing in the main heading, and so the type of that particular cell is set to heading 1 while I'm typing. And the IPython notebook consists of different cells, and each cell can be of a different type, and that's the real strength of it, because it lets you interleave the different types of things you might want to do, like notes and code and the output of graphs and so on. So the cell types at the moment are headings, code, and that can be not just Python code, but other types of code, markdown, and raw text. So when I press Shift-Enter, the focus moves down a cell, and again, when I took the screenshot, the focus is another cell down. I wasn't quite careful enough when I was taking my screenshots. So in this case, the focus is now already on the date cell. And I also just wanted to quickly run through this page layout. That's the sort of page layout I've been using for my notebooks. So I use a heading that gives me the topic of that particular, like which little part of my research that particular notebook pertains to. And then I have the virtual environment I've been using for that particular notebook. So if I go back to it months later and it doesn't work, I can actually go back and load it in that old virtual environment instead, and hopefully have it work again. Because all of this science stack, that's the thing that makes it absolutely wonderful to use, is it's improving incredibly fast. Like even week to week, you see significant improvements in the software you're using. And then I usually use date headings, again, because with research, you'll work on an idea, then you might sort of take it through to the end of where you're thinking at the time. Then you might come back even months later to re-look at that idea and work it forward further. And so it's really handy to know, like, just that sequence of when you worked on things. You can use the view menu to toggle the header and that. I don't normally need to do that, but for presentations you need to get them out of the way to just have more of the screen visible. So, just to recap on that introduction, the most important things I find for research about IPython are this ability to interleave my notes and my code and the output from the code in the one document that you know, you can see everything and understand what you were thinking at the time. And the other part of it, the other really important feature for me is the ability to share notebooks that Jessica also touched on, because that is becoming increasingly critical. I think if you're interested in open culture and open source, then open data is a really important part of that, and reproducible research. So you really want to be able to try to contribute towards that. So they've introduced the notebook viewer, and this is the notebook viewer website that lets you share your notebooks. So if you put your notebook somewhere on the internet or as a gist on GitHub, then you can just type in the URL or the gist number on this site, and it will create a read-only version of your notebook that other people can then browse. It will also create a link back to the notebook so people can actually download the notebook to run locally if they want to. Getting your data to them can be a whole other issue, but this is a good step in the right direction. Mostly at the moment it's being used for examples and tutorials and books and things, but it is starting to be used for reproducible research. So now I'd like to just run through some of the more minor sort of features of IPython Notebook that I've found personally very useful. So the help features, because I only started using IPython after seeing a talk about IPython Notebook. So I've only been using Python for about 2.5 years. So learning Python, it's the help features of IPython Notebook really good. There's a help menu. On the slide what I'm showing is where you can put a question mark after the thing you want some help from and then run the cell, and it will bring up the help for that particular thing in a window at the bottom of the screen. In this case I've made the window much larger. It doesn't usually take up half your screen, but again, to show you what's going on, I've made it very large. That same type of help is also available if I just put in like the bracket, function name bracket and then press tab. I'd get a tooltip style help that would prop up just there that would tell me what parameters are now available for me for that function. And if I press tab a second time, then I'm into this type of help where it's popped up in the bottom of the screen. The other thing you can do is use a second question mark, and that then, if the source code is available, that will then load the source code for the thing that you're calling into that lower window. And I've found that really useful, especially with some of these rapid moving libraries that you might be using. If they haven't got the right sort of documentation in their header for those doc strings to come out and help you with their calls, or sometimes the doc strings are just plain wrong because they haven't been updated but the parameters the thing expects have. By actually browsing the source, you can have a much firmer understanding of what that code is really doing right now rather than what somebody said in the doc string when you have problems. So it's great for understanding libraries. The other part of IPython Notebook that I've found really powerful are the magic functions. And they're utility functions for saving things, running external code, and They can act on either a single line if you use a single percentage mark in front of the command, or if you use 2 percentage symbols in front of the line, they'll act on the whole cell that you're currently working in. So I'll just run through the top few, 4 of those that I've found most useful. Oh, and also, like everything, like these, you can get the help on by putting the question mark after them as well, so if you want detailed help on a particular one. So the first I'd like to mention is Timeit, which lets you get the execution of a line or a cell. And so this is an example of how I've used Timeit to test the speed of accessing a Pandas data column, because part of what I've been learning is how to try to do things efficiently. And so in this case, there weren't huge differences in the speed of accessing it through the built-in pandas.map function versus using a list comprehension. And even with the list comprehension, I thought maybe there's a difference between the couple different pandas ways of actually referring to the particular column, because I'm sort of finding sometimes there can be quite surprising differences depending what the underlying code's doing. So I was also pleasantly surprised on this that, see, that's run through 800,000 records and lowercased them all in each case. So it also shows the other good thing about Pandas and IPython Notebook is that it can be incredibly fast for things that would otherwise, you know, if you did them with different ways, could be a lot slower. Okay. The next one is Pastebin, which just lets you create a gist on GitHub if you want to get some help with your code and share it. And then Load and Save, which lets you save out a cell or a range of cells, or else load a file into a cell. And finally, the run command, which lets you run an external script. And again, like I mentioned earlier, you've got to remember with IPython Notebook that this will then, having run that code, all of the symbols from that code will be loaded into your interactive namespace, and all the so all the functions and all the variables that you've set will be accessible. So I'm using this particular one in lots of my different notebooks to just keep the look of my graphs consistent across the different notebooks. Okay, so let's move on and have a look at Pandas. Pandas is the main data analysis tool that I'm using, and it provides some really useful data structures and also analysis tools. And it also works really well with other parts of the SciPy sort of stack, so everything tends to interwork really well. 2 main structures I'm using are the series, which is like an array or a single column of data, and then the data frame, which is like a table of data. And the other feature for me, because Twitter data is inherently time-based, is that Pandas has really strong time-based indexing. So let's have a look at how the things I'm finding useful in Pandas by looking at a few code examples. So first, as I mentioned in the introduction, I'm working on tweets containing the word science. So I originally collected about 13 million tweets, and I've since filtered out some spam and some non-English tweets, so I've now still got about 12 million tweets. And I use IPython Notebook and Pandas for that filtering as well. Tweets are interesting because they've got lots of metadata. There's not just the text string of the tweet, there's also who sent it, who they sent it to, maybe some geolocation data, all sorts of other, interesting bits of metadata that come along with each tweet that you get. So for today's talk, I'm just going to look at the number of tweets per day. And that's sort of cheating in a way, because it's getting you down from big data into 1 record per day in 2011. So you're going from a big problem to a much smaller one. So I'll walk you through this code to demonstrate how easy Pandas makes it to do that collapsing, and then we'll do some little bit of exploring of that tweets per day data. So the first thing we have to do is get at the tweets per day into Pandas. And mine are currently stored. I've tried different backends over time as I try to get it faster. And at the moment I'm using CouchDB. And so I create a view on CouchDB that does that compression for me, because then I can just let it run. It doesn't matter how fast it takes, because it's just happening in the background. Once that view's created, then I can use that to extract the tweets per day, and I'm only trying to get those one record per day from the database, so it's quite quick. So I run this query loads the tweets per day, and I make those returned results into a list. So then the list returned from CouchDB is used to create two new lists. First, a date list, which is Pandas date times. And I'll mention later why I do my dates and times in that particular way, why I've taken the text date time and used the Pandas date time to make it into a date time. And a data list, which has got the number of tweets on each of those days. So those two lists are just like, there's one record in each that have to line up. Then I convert the date list to a date time index and create the science tweets series. Another really useful thing from Pandas is it's got very good handling for missing data. And otherwise, if you don't have good handling for missing data, it can be quite hard to decide how to flag missing data. You really want to be clear whether something is 0 tweets were sent on that day for some peculiar reason, or whether the 0 is for a stupider reason, which is in my case on April Fool's Day in Australia, which I thought was really good timing. It was the 31st of March UTC, but still. My research computer, the one that gathers the tweets, is an old repurposed computer, and it ran out of disk space on its primary position and couldn't store any more data. And it also couldn't create the email that I expected it to create to tell me it had a problem. So a little bit of a design flaw there, which I've since rectified. The emails get created on a different petition. But so it took me actually quite a few days to notice, because this thing just runs. It's still running in the background now, and it just runs away happily doing its thing. So it was about 4 days later that I actually noticed that, hey, I haven't been getting any of those emails that I usually get that tell me, there's some little funny things happen on Twitter, and it tells me about those. So and it then took me quite a few days to, I realised I had an outage that I'd have to handle in my analysis, so I didn't sort of take too much care about getting the new hard disk. So it was finally fixed on the 12th of April. So on the 31st of May and the 12th of April, we've got partial data, and then we want to exclude those and all the days in between. And in Pandas, what we do is we change it to a float so that we can then set it to NumPy, not a number, and that's how Pandas then will flag that as missing data for us. Yep. So another feature is that it's really easy to check interactively that things are working the way you expect them to. So in this case, it's a bit confusing because I've masked out a bit in the middle, but what I'm doing is just checking that the start of my series and the end of my series are the start and end of the year as I'd expect, to make sure I've extracted the right stuff out of the database. And we can see that it is. And then the next thing I check is that the masking out of that missing data has worked. So in Pandas, this is how easy it is to do a nice graph to start exploring your data visually. You just say data frame or series dot plot, and you'll get the default graph. And then you can start fiddling with that if you want to refine that graph. So in this case, we can see a couple of things. We can see that it has masked out the missing data, and also that we've got some sort of periodic pattern happening with our data. So let's explore that further. This slide's just showing many ways to access the first or last items. So that's part of, again, with Pandas, you often do have a little bit of, I think it's partly it's developing so quickly that it hasn't yet found the one right way to do things. But that flexibility can be really handy. So before I used the 1 day, and it's also possible to get like the first week of the year. Lots of different ways of accessing date ranges. Sorry, was there anything else? Yep, that's fine. So I mentioned earlier about that I'd tell you a bit more about dates. Dates can be a really difficult problem in lots of different types of software, both working with date ranges and making sure you're using the right dates. So I always use, after being burnt quite early on with some of the things I did, I now use everything as UTC dates so that I absolutely know, I don't have to sort of think, oh, was this one in this time zone or that time zone? I just keep everything as, I make sure I always make everything into UTC dates as soon as I get them. And most software also, being American-centric, tends to default to month-first date strings. So that can be really confusing for us sort of countries that have day-first date strings. And it can be quite ambiguous. So that's why I still use always the Pandas date-time function, because then it's expecting year as a parameter, month as a parameter, and day as a parameter. So it's much harder for me to get that ordering wrong, or to have it, I mean, one of the problems with parsing is you'll often have it sort of go wrong without you noticing, because the thing will have parsed the date the wrong way, and it'll look reasonable still. It'll still be a date, but it just won't be the one you expected. Pandas has now introduced a day-first parameter to most of its day parsing, so that might be an option for the future, but I think I'll still stick with being quite explicit. So if we zoom in on the earlier graph, we can see the we zoom in on the earlier graph using a date range. We could also have used an index range. So now we can see that pattern in a little bit more detail. So we can see now that there seems to be about 4 peaks per month, so maybe that pattern's weekly. We're just getting a little bit more understanding of what that pattern might be. And also, it'd be interesting if it is weekly, well, which days are the peaks and the troughs, if it is that regular? So here we zoom in further, and add labels on Tuesdays and Saturdays. Now, you can see here that there's a lot more lines of code to do that. That's because I'm now overriding that x-axis default formatting, and it turns out that Matplotlib doesn't understand Pandas date times. So once you want to start overriding a time-based axis in Matplotlib with Pandas data, it's better to actually go right out to Matplotlib in many cases and pass the Pandas data to Matplotlib as Python date times to make sure it works. So that's what's happening here, is that first of all, I create the slice out of, I might as well not pass Matplotlib the whole Pandas series. In this case, it's a small one. I could have, but in many cases, I'm working with really big ones. So it's better to pass Matplotlib just the bit of the data I want it to plot. So first of all, I slice that bit of data out of the Science Tweets series, and then I call Matplotlib with the changing the index, which is the date time index, into a PyDateTime instead, so that Matplotlib will be able to understand it. So now we can see that there do seem to be some peaks in the middle of the week and dips on weekends. So people are using the word science more at work or at school in the middle of the week than they are on weekends. And this actually reflects a broader pattern of Twitter usage, that generally people do use Twitter more at work than at home. Don't know if that's a good thing to be putting out there. So the other thing, so we've sort of explored that a little bit. Now we might want to try resampling, like we've been looking at daily data. So Pandas makes resampling time series incredibly easy. So that first line on that slide just shows how we resample that data set into a monthly data set instead of daily, and I'm saying the how is mean. You can use lots of different ways of telling it how to average that data, you know, how you want it to create that data point. And again, then we can just go back to the default plotting. And another nice thing, you can see here how easy it is for me to just quickly chuck both those things onto the same graph. I've just called plot twice. Pandas in the background's done the nice thing of whacking them on the both onto the same graph. So we can see the monthly, by doing it monthly, you obviously smooth out the data a hell of a lot and you lose that weekly variation. Pandas also provides a range of data analysis options, and so this would be the most basic starting point that I'd usually use, which is just describe, which gives me an overview of the statistics for that particular data set. And so it's showing us the count and the mean and the standard deviation and so on. And I also mentioned earlier that it works really well with other tools, so it's very easy to then, if you need some more advanced things, you can interact with stats models and so on when you need more advanced. So I've done some Fourier analysis on this because it is a regular series. So we can make a data frame in various ways, but one way is by combining different series together. And again, another big powerful thing of IPython, of Pandas, is this aligning of the series of different lengths and different frequencies, which can be a really hard problem with time series. And it just does that and puts in the not a number, the missing data, where it doesn't have something in one of the series that you're combining. So it just aligns them and creates your table. We can add columns easily, so we add a cumulative column and then go through and calculate the total tweets so that we can then add a percentage column and so on. So, and then the final thing I wanted to talk about was the group by function, which is which lets us reshape that table. So we've got at the moment one that's got some missing data and it's got a year's worth of data and we've got various columns in it. So we then say we want to group by days of a week because we'd like to see the overall pattern of what happened on each day of week. You have to remember when you're doing that, it doesn't know what your columns mean. So doing that for these two columns is just meaningless. Like, it just doesn't make any sense for them to be looked at by day of week. So then we want to exclude them out of the table, and we can do that really easily with this column selection method. And so we can then check that our percentages sum to 100 and that the sum of the tweets per day was the same as the sum of the tweets per week. And then the final feature is that we can export data frames to lots of different formats. So here I'm using it to create a LaTeX table to include in a document. I could also export it as a pickle, a CSV, or lots of other formats. Oops. So thanks very much for coming to my talk. And the slides and the IPython notebook will be up on GitHub shortly.